In this video, I'll be explaining what the various options on Throttlestop do, and also teach you how to use them to undervolt your laptop CPU. We've recently been facing a lot of issues on modern laptops. Issues like overheating, thermal throttling, power limit throttling, and a whole host of other annoying problems. These issues are more prominent on gaming laptops. The interesting thing is that most of these problems we face can be fixed by simply undervolting our laptop CPUs. According to Techopedia, undervolting is a process through which voltage to computer processors and components is decreased dynamically on runtime. It's a process within dynamic voltage scaling that enables conserving electrical voltage to reduce energy consumption and heat produced by competing components. I'll also add to that definition by stating that undervolting, when done properly, does not have any negative effects nor hamper performance. Instead, it does the opposite by giving your laptop better performance along the line. Undervolting a laptop CPU is very easy, contrary to what you might be thinking. All that is required is a free undervolting software and a working brain. There are two most popular software for undervolting. They are Throttlestop and STU. Throttlestop by Uncle Web, in my opinion, is the best software for undervolting any laptop CPU. You must have noticed that I'm specifically talking only about laptop CPUs and not their desktop counterparts. This is because most desktops do not require undervolting. Instead, issues like overheating and thermal throttling can be fixed via other methods like adding more fans or water cooling the PC components. Also, desktops rarely have power limit throttling issues since they generally have larger power supply units that are able to supply the necessary current to all the PC components. There are many advantages to undervolting a laptop CPU. These include better battery life, a reduced laptop temperature which equals less heat, a better performance which is quite obvious since your laptop would no longer throttle due to high temps or reaching its power limit. By undervolting your laptop, you're indirectly increasing its lifespan. Heat is what kills most laptop components, so it's a no-brainer that less heat would mean that your laptop components get to live longer. And how do you reduce laptop heat? Well, by simply undervolting your laptop. Having known what undervolting is all about, how it works, and its various advantages, I guess it is time to dive into the topic of today's guide, which is how to use Throttlestop. Check this video description below for a link to download the latest version of Throttlestop for Windows, which at the time of this video is the version 8.70.6. Once that is done, you should install and launch the program. In the home menu, you will find lots of options that I will be discussing straight away. Here we have clock modulation. This allows you manually throttle the CPU by setting it to perform only to a certain percentage. Setting this option to 50% means that your CPU will be throttled to only perform up to half of its full potential. That will be 2.0 GHz on the CPU with a max clock of 4.0 GHz. This option, however, is no longer used on modern CPUs and it's no longer effective even when enabled. And we have chipset modulation. This feature is pretty much the same as CPU modulation. I believe they work together. It's also an obsolete feature on modern CPUs and can't be enabled in most cases. And here we have set multiplier. This feature used to be useful on older CPUs for controlling the CPU clock speed by using a multiplier. It is now also obsolete and it's best to leave it disabled. And here we have speed shift, EPP. This is a non-software method to control CPU behavior. It replaced the older speed step feature on CPUs before Intel's Skylake. Because this option operates on a hardware level, it is expected to be more effective than speed step. That is why I use it. You can set this option to values between 0 and 255, with 0 being the value to make your CPU perform at its max clock, while 255 does the opposite by keeping your CPU running on the lowest clock possible. 32 is the sweet spot for me on my gaming profile since it enables the CPU to raise its clock to the max most of the time and let it clock down when necessary. I prefer to use a value from 128 and above on my battery saving profile since this keeps my laptop running smoothly, but not on too high clocks that would consume its battery faster. The highest value, 255, will significantly slow down your laptop, so I don't advise you to use that, not even on a battery saving profile, unless you won't be using your laptop at all during the time though. Just so you know, EPP is an acronym for Energy Performance Preference. The next option is Power Saver, which is usually blank until you enable disable turbo option. It's a feature that is meant to further complement the effects of disabling turbo option. It instructs your CPU to use lower clock speed when idle. However, this is no longer needed on modern CPUs since speed shift kinda does the same thing. Then we have the disable turbo option. I believe its use is very obvious, but I'll go ahead and explain it. It's an option that disables the Intel Turbo Boost feature on your CPU. Take my laptop CPU for example, a Core i7-7700HQ. It has a max clock of 2.8 GHz and a max turbo clock of 3.8 GHz. Taking the disabled turbo boost option would limit the CPU to its base clock of 2.8 GHz since it would no longer turbo boost. I, however, advise that you turn off turbo boost from your laptop BIOS if the option is available, rather than doing it from the turbo boost program. You should also note that it is not necessary to use this feature unless you are willing to let go of some performance for lower terms. The only scenario where this option would be a lifesaver is when the undervolt you've done on your CPU is still unable to stop it from power limit throttling. That is when this option could come in handy since it prevents your CPU from turbo boosting and requiring too much power to do so, which in turn leads to power limit throttling. Aside that, I always keep this option unchecked and I advise you to do so too. Next we have the BD Project option, which in its full form stands for Bidirectional Processor HOT. It's a feature that prevents damage to your laptop components by immediately throttling them down when the CPU temps become too high. It is triggered when the CPU reaches its max temperature, say 100 degrees Celsius or thereabout. Sometimes this feature may be triggered when another component like the GPU reaches a set temperature, which can be very annoying. To prevent that from happening, you will need to uncheck the BD Project option. However, this would also mean that your laptop won't be throttled even when its CPU temperature gets too high. My verdict is that you should keep this option unchecked because I doubt that your laptop CPU would ever reach its max temperature to trigger the Project feature after you've undervolted it. And here we have taskbar. This is usually unchecked by default and should be left that way. Checking it would mean keeping Throttlestop on the taskbar when minimized rather than on the tray. And we have log file. This is another self-explanatory option. It is simply used to log your Throttlestop records on a test document that will be stored in the Throttlestop folder. You should turn this off when you don't need to log any records. Then we have stop data. Use this option to disable Throttlestop sensor monitoring services. Useful when using other monitoring programs like Hardware Info 64 in order to prevent any interference. Then we have speed step. This is a software level method for controlling CPU speed. It was used on CPUs before Intel Skylake and has now been replaced by speed shift. Unless you have a CPU before Skylake, it is usually best to keep this option unchecked. And here we have C1E. Disabling this option is mainly known to prevent the turbo boost option from shutting down cores automatically. This, as you may have already guessed, would cause an increase in power consumption, which is a bad idea if you're looking to fix power limit throttling on your laptop. Therefore, you should leave it enabled. Next option is on top. This works similarly to the allow to draw on other apps option on Android devices. Enabling it would keep the Throttlestop window on top of any other program windows. And here we have more data. This option reduces the refresh rate of Throttlestop's recording and monitoring services, thereby allowing it to log more data per second. The value is said to be 8 times more data per second when this is checked. Now onto the right, we find the CPU reader box that reports different kinds of data concerning the present state of your CPU, which is of course never custom. On top of the box, you will find your CPU model, the current voltage, and finally the current clock speed that your CPU is running at. Inside the box, you will find columns of data which represent the different threads on your laptop CPU. My i7-7700HQ has 8 columns because it has 8 threads, which since it supports hyper-threading. Yours may be different depending on the number of your CPU cores and if or not it supports hyper-threading. The columns are under 6 rows of data which have the following titles. FID. This represents frequency identifier. This column tells you the current clock speed of each CPU core. See 0%. This is the percentage of time in which your CPU thread has reached its max performance. The value is usually higher when under load, such as when gaming, because your CPU is usually pushed to its limit in that case. As expected, the value is noticeably lower when idle. We have MOD. This is a reading for the clock modulation I talked about earlier. The value should always be at 100% on a modern CPU since this feature isn't being used. Next we have temp. This is the current temperature of a particular core in degrees Celsius. Two columns that are beside each other usually have the same reading since they are representing the same core on CPUs with hyper-threading feature. Here we have max. This shows you the maximum temperature that a particular core has reached. The red data is represented like it is on the temp column. Beneath this box, we find some other useful readings, which include package power. This tells you how much your CPU is currently drawing in watts. We have temp, the current temperature of your CPU as a whole. This is usually represented by the temperature of the hottest core. Here we have limit. You can also click on this option to know if your CPU has throttled and why. Also, besides it, you will find two readings: a TDP throttle reading with a circle in front and a protrude box with a square in front. If the circle beside the throttle reading is filled, it would mean that your CPU has throttled due to either reaching its max power draw or its designed thermal limit. If you find the box next to protrude option to be checked, it means that your CPU had throttled due to hitting its max safe operating temperature. I guess this would only be the case when the BD protrude option I discussed earlier is enabled. Just below these readings, you will find 5 buttons. They are FIVR. This is an acronym for Fully Integrated Voltage Regulator. It is the most important option of all the 5 buttons because it's from this option that we would undervolt our CPU. I'll get back to it after explaining the other buttons. TPL, the second most useful button of the set. TPL is an acronym for Turbo Power Limit. It is from this option that you can enable Intel's speed shift feature on supported laptops and notebooks that do not have it enabled by default from the BIOS. We have BCLK. This button is used to force a refresh of Throttlestop's reading of your CPU clock speed. Here we have a letter C with usually any number from I think 1 to 8. I don't fully know what this option really does yet. All I can say is that it works as a CPU load meter that indicates how much load your CPU is currently handling or something of that sort. Please let me know in the comments if you know exactly how it works. Here we have DTS. This shows the reading of the digital thermal sensor on the CPU chip. The closer its value is to 0, the hotter the CPU is running. We have CLR, which is short for clear. Pressing this button will clear and reset the Throttlestop temperature throttling records. The rest of the buttons on the bottom of the page are fairly easy to understand, such as the save button, which is used to save your Throttlestop settings, the battery button, which displays the battery level of your laptop, which I personally find its ability to display your remaining battery capacity in mAh when clicked to be very useful, like this. You have to click on the buttons 4 times and it will display the remaining capacity of your battery. As you can see, mine is currently at 47.541 watt per hour, so that is very useful for me. The GPU button shows you your NVIDIA or AMD GPU temperature. You can view the current minimum and also maximum temperature reached by the CPU by pressing this, the GPU by pressing this button. The turn off or turn on button is used to turn Throttlestop's function on and off. You always want this to be on, else your Throttlestop settings won't be in effect and it would only be running in monitoring mode. The TS bench option is used to stress the CPU. It is Throttlestop's own CPU stress test. You can use this to test for stability alongside other stress test programs, which I will talk about towards the end of this video after undervolting our CPU. The options key takes you to Throttlestop's options menu, where you would need to enable a couple of options, and we'll be doing that right away. This is Throttlestop's options menu, and I'll quickly talk about the important features on this menu. Important options on this menu which you should use. Normally, Throttlestop comes with 4 profiles, which are named performance, game, internet, and battery. And you can rename these profiles if you want, but I don't usually see the need because they still function the same way. Though for personalization, you may want to do that. And here we have a very important feature. These are default profiles. I have 2 profiles which I use regularly. I have the performance profile, which is profile 1, and battery profile, which is profile 4. My performance profile is the profile I use for gaming and any other task that requires my CPU to perform at its full potential. So here you can see default profiles, AC profile. Usually I play games only when my laptop is connected to AC, and that is also when I do more taxing tasks on my laptop. So I have the AC profile set to profile 1, which is performance, and here I have my battery profile set to profile 4, which is battery. What this means is that when I connect my laptop to AC, Throttlestop automatically switches my profile to profile 1, which is performance. And also when it's unplugged from AC, when I'm running on battery, Throttlestop automatically switches my profile from profile 1 to profile 4. I have different settings for these 2 profiles. I have different settings for performance and different settings for battery. I also have different undervolt values for both. On performance, I have a speed shift setting of 32, that is the value on speed shift, while on battery I have a speed shift setting of 128. I already explained this while I was explaining speed shift, because having 32 on performance means that my CPU is usually running on high clocks, while having 128 means that my CPU is usually running on lower clocks. So that is it. And on miscellaneous, you see the options I have enabled. I would advise that you enable the same options and leave the other options which you do not need as they are. You don't have to touch them. Important options you should enable here are start, minimize. This option would help you to prevent Throttlestop from popping up when you turn on your PC or when you start up the program. Normally when you start up Throttlestop, it pops on your screen, but using this option would mean Throttlestop, when it auto starts or when you start it, it will start in the background and it wouldn't interfere with whatever you're doing. And we have minimize and close. Usually we use the close button sometimes without intending to do so, and this may close Throttlestop. So it's best to click this button to make Throttlestop minimize even when you use the close button. And another option to check out is the NVIDIA GPU or AMD GPU option. I ticked the NVIDIA GPU option because I have a dedicated NVIDIA GPU graphics card on my laptop. You should tick the AMD GPU if you're having an AMD GPU on your laptop. But if you're having an NVIDIA GPU, you should make sure to tick this option. If you don't tick this option, Throttlestop will not be able to show your GPU temperature even when you click on the GPU option the GPU button that I talked about earlier. These are the only options that are worth checking out. Another option you should want to check out is alarm. This alarm is useful if you want Throttlestop to notify you or to use a particular profile when your CPU goes over a certain temperature. Let's say you want Throttlestop to go down to the battery profile if your CPU or GPU goes over 105 degrees Celsius. You should tick this alarm option. So when your CPU goes up to that temperature, Throttlestop would automatically use the profile you have chosen. I don't use this option because my CPU has never gone up to a temperature which I'm uncomfortable with, so I'm fine. That is all for this page. should leave every other thing on default unless you're sure you need to use them and you know what they do actually. Aside that, I think we are done with this page. Hello guys, I decided to split this video into different parts. So in the next video I'll be going directly to teach you how to undervolt your laptop with Throttlestop. I'll link the video down in the description, so be sure to check it out. And make sure you subscribe to check out the other parts of the video I'll be releasing soon. Peace.